There are two methods to calculate the volume of a solid of revolution. The first method we talked about in the last talk is called the disk method. And the idea is you have some region in the plane, and let's say it looks like this, and you rotate it around an axis. So in this picture, I'm rotating it around a horizontal axis, maybe the x-axis, and it sweeps out a solid. And if you take any cross-section perpendicular to the axis of revolution, the cross-section is a washer. It looks like something like this. And we can figure out the area of that washer. It's the area of this circle minus the area of the inside circle of the hole. If this top curve is y equal f of x and the bottom curve is y equal g of x, then the area of this washer is pi times f squared minus g squared. You multiply it by a certain thickness dx and add over the region from a to b, and that gives us the integral. So this very beautiful formula is a way to calculate the volume of a solid of revolution by looking at cross sections perpendicular to the axis of revolution. So here's an example from the text. It's example 4. We look at this curve from -4 to 4 and rotate it around the x-axis. So the graph of this, from -4 to 4, when x is plus or minus 4, this is 0. When x is 0, this is 1. The graph of y minus x squared over 16, it's a parabola. It looks like that. And when we rotate this around the x-axis, we get a kind of a pontoon. What is the volume? The volume is pi. X goes from -4 to 4. This squared minus this squared. Well, this is just 0. So it's just the function 1 minus x squared over 16 squared dx. So when we calculate this, it's pi integral -4 to 4. When we square this, we get 1 minus x squared over 8 plus x to the 4th over 16 squared, which is 256 dx. What is the integral? The integral is x minus x cubed over 3 times 8, which is 24, plus x to the 5th over 5 times 256. Evaluated from -4 to 4. So you just plug in the numbers and you calculate. When x is equal to 4, you get 4 minus 4 cubed over 24 plus 4 to the 5th over 5 times 256 minus this with a -5, it just doubles it. And if you do the arithmetic, you get, I think, 64 pi over 15. So this is just the calculation you need to do to get the right answer. But the intellectually more difficult part is understanding how to set it up. So it's reduced to an integral that you can do. Now there's a second method to compute the volume of a solid of revolution, and that's called the shell method. So in the disk method, you're looking at a cross-section perpendicular to the axis of revolution, and that cross-section is a disk or a disk minus an interior disk. In the shell method, if this is the axis of revolution, this is what you're rotating around, you take a cross section parallel to the axis of revolution. So let's say you have a small rectangle and you rotate that around this axis, you get something like a pipe or a shell. If the width is h, or let's say the length of this pipe is h, if the distance to the axis of revolution is p, and the thickness of this little rectangle is w, let's say the distance from the midpoint of this rectangle to the axis of revolution is p. If the width is w, this top height is p plus w over 2. The bottom height is p minus w over 2. Now, when you rotate this shell, it sweeps out a cylinder with a hole in the center. So if you take this big cylinder, what is the volume of that cylinder? So the radius is p plus w over 2. So pi times p plus w over 2 squared, that's the area of a cross section of this big cylinder, times the length h. So if you just took this rectangle, rotated around the x-axis, you get a cylinder of this size. What about this smaller rectangle? It's the distance to the x-axis is p minus w over 2. So that squared times h is the volume of the smaller cylinder. And if you subtract, you get the volume of the shell. So this is really the critical formula which leads to the integral. So the volume of the shell is this difference. When you subtract, there's a lot of cancellation. You just get 2 pi phw. P is the distance from the center to the axis of revolution. H is the length of this piece. And W is the thickness. And if you put this together and you're taking a general region in the plane and rotating it around an axis, let's say you're rotating it around the x-axis, the formula for the volume of revolution by the shell method, just keep this formula in mind, it's 2 pi. P is the distance to the axis of revolution. H is the length of your piece. And W is the thickness. So when you have a horizontal axis of revolution, this is the formula by the shell method for the volume. So I went over this a little bit quickly, but it's described very nicely with clearer pictures in the book. And that's what you really need to study to understand this. When you have a vertical axis of revolution, you have the analogous formula, and this is it. So let me do 2 examples of computing a volume by the shell method. These examples are in the book, so it's really helpful to study the book to understand what's going on. We want to find the volume of the solid of revolution formed by revolving the region bounded by the graphs of the following curves. X equals e to the minus y squared. So here, x is a function of y. This curve is really the bell-shaped curve that you see all the time, but with respect to the y-axis, the bell-shaped curve. And from y equals 0 to y equal 1, this is the graph. So from the x-axis up to here, we're going to take this region and rotate it about the x-axis. At any point y, between 0 and 1, let me just write down the formula for the Chalmette method over here so we can refer to it. So the volume is 2 pi integral from C to D, P of y, H of y, dy. And P is the distance to the axis of rotation. So in our case, first of all, C is 0, D is 1, P of y is y, because we're just rotating around the x-axis. So for any point on this horizontal of y, the distance to the x-axis is y. And H of y is this length. H of y is e to the minus y squared. So we get the volume is 2 pi integral from 0 to 1, P of y, H of y, dy. That's the formula, of course. It's only useful if you know how to do the integral. Let me write this as pi integral from 0 to 1, e to the minus y squared, 2y dy. In fact, I'd rather multiply by minus and minus. So now if I make the substitution, u equal minus y squared, du is minus 2y dy. This becomes minus pi, the integral of e to the u du. And when y is 0, u is 0. When y is 1, u is minus 1. So this is minus pi, the integral of e to the u is e to the u from 0 to minus 1. So this is equal to minus pi e to the minus 1 minus 1. Or it looks a little prettier if you write this as 1 minus e inverse times pi. That's the calculation. Let's do one more. So we want to find the volume of the solid formed by revolving a certain region, and this time we're going to revolve it around the y-axis. And we take y equal x squared plus 1 from 0 to 1. So that's just this parabola from 0 to 1. And we're going to revolve this region about the y-axis. What that actually gives us is a kind of a cup. So what is the volume? The volume is equal to pi times the integral from 0 to 1 Well, let's be a little bit more careful. We're going to revolve this around the y-axis, but there are actually two different parts to this. Let's look at this horizontal line. So when you revolve the lower half around the y-axis, so this is the integral from zero to 1 for every y. Let me start this again because I was going to do this problem in two ways. First by the disk method and then by the shell method. But part of the object of that was to see that in this instance, the shell method was easier. But let me just do it by the shell method. So in this case, as x goes from 0 to 1, we look at cross sections perpendicular to the axis. And for this cross section, so this is the integral of pi, the integral from 0 to 1. For every x, the distance to the axis, the height, this distance, is equal to x squared plus 1. And the distance to the axis of rotation is x. So this is the integral of pi times the integral from 0 to 1 of the height of the shell, x squared plus 1, times the radius, or the distance to the axis, which is x, dx. And this is pi integral from 0 to 1, x cubed plus x dx, which is pi x to the 4th over 4 plus x squared over 2 from 0 to 1, which is pi times a 4th plus a half of 3 pi over 4. You can also do this by the disk method, but in the disk method, you have to break it up into two separate pieces. You have a pure cylinder plus this is another piece. So this is the shell method, and we'll go through a number of problems using the shell method as well as the disk method in the homework.